Hello, welcome back to the channel. So let's continue our discussion on numerical integration, and in this video we have to write out all the three approximations of this integral using n equals 6. And by all the three approximations we mean midpoint approximation, trapezoidal and Simpson's approximation in this question over here. So we have to use all these three methods and get three separate answers for all these three approximations. So this question will be divided into two parts. In this video we'll cover the midpoint approximation, and in the next video we'll cover the trapezoidal and Simpson's approximation in order to approximate this integral using the methods of numerical integration rather than theoretical integration that we already covered in the last videos, right? So now we have to evaluate this integral, but before evaluating this integral using midpoint approximation, we need to know what midpoint approximation is, or what the formula for the midpoint approximation is. So this midpoint rule approximation is similar to the right hand Riemann sum approximation. The only difference is your xi's in this case. In order to calculate your xi's, you first calculate your xi's from the right hand Riemann sums by using that formula. So you know the formulas about the right Riemann sums, right? So the delta x calculation is always the same for all the three approximations, and delta x is basically b minus a over n, where b is your upper endpoint in the definite integral, a is the lower endpoint, and n is the value of the n which is given in the question. So delta x remains the same in all those approximations, but the only difference in this approximation is the calculation of xi's. In order to calculate your xi's for the midpoint rule approximation, what you will do is you'll first calculate your xi's based on the right hand Riemann sums, and then you'll take these means, which we will discuss in this video. So what you have to do is you'll first calculate your xi's using the right hand Riemann sum, and you know about your right hand Riemann sum that in order to calculate the xi's for a right hand Riemann sum we use a plus I delta x formula, right? So now what you'll do is you'll start from your x0 all the way to your xn and calculate the values of these variables over here. So in this case, since n is 6, this would be basically calculating x0, x1, x2, x3, x4, x5 and x6, right? So once we have calculated all these xi's using the right hand Riemann sum formula, we will take the midpoints of these xi's, and by taking the midpoints of these xi's, we will get the xi's for our midpoint rule approximation. And then we'll use the same formula which we used in the Riemann sum approximations in order to calculate the midpoint rule approximation. So if we start with calculating our xi's using this formula, x of 0 is basically a, right? And in this case, a is 0 in this case, our b is 30. So let's calculate delta x first. So since b is 30, a is 0, n is 6, our delta x is 5 in this case, right? So your first value, your first xi is x0, and it is equal to basically your starting endpoint, right? Because if you substitute 0 in this formula, it would simply be a is 0 in this case. And then if you'll calculate your x1 would simply be you'll add 5 because you're incrementing every value by 5 units. So your x1 would be 5, x2 would be 10, x3 would be 15, x4 would be 20, this would be 25, and x6 would be your b, which is 30 in this case, right? So this is your 30 in this case. So now you have your xi's of your right hand Riemann sum rule. In order to calculate the xi's for your midpoint rule approximation, you'll calculate the midpoints of these values, right? And if you'll do that, it's easier to plot them on a number line and then calculate the midpoints based on your xi's. And when you'll do that, you'll basically get your xi's for your midpoint rule approximation, which you can see on the screen as well, right? So now if we want to calculate the midpoint rule approximation, we know the f of x is basically this function over here. So we know that f of x in this case is 1 upon x cubed plus 1. And then we know about our other variables as well. Delta x is basically 5 that we calculated over here. Delta x is 5. And now in order to calculate the approximation, so the midpoint rule approximation would simply be delta x times f of x1 bar plus f of x2 bar, so on until f of x 6 bar in this case, right? Because our n is equal to 6 in this question. And if you'll calculate that, you'll substitute all the values in this case. So it would be simply 5 times f of 2.5, f of 7.5, f of 12.5, and then so on, 17.5, 22.5, and then 27.5 in this case. And for calculating these values, you'll basically substitute the values inside the function into this expression to calculate this whole expression over here. And when you'll solve this whole expression, you will get the answer of your midpoint rule approximation for this integral over here with the given endpoints. So this was all about calculating the midpoint rule approximation of a definite integral using numerical integration. So that's it for this video. Feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.